Okay, so for the second part, I'm going to give you another example. We are going to do some practice on the MRI angiography. This is kind of the spatial techniques for MRI that we can image. We can image or we can see the vessels using MRI, okay? And of course, because vessels are the 3D structures, so we also need to do the process on this kind of the 3D images. So right now, I'm going to ask you to change a little bit what you have on the hand. In the first example, we actually import 192 images from MRI underline 3D T1 folder, right? But now please check. You do have another data folder. Just check right here. Previously we used this one, right? But actually, for the second part, we are going to use this part, MRI underline TOF right here. And for this MRI TOF right here, you can see actually we only have 136 images, DICOM images within this folder. So you can again read all the DICOM files into Workspace. You can again save it as a 3-dimension image variable, okay? So now you can see if you successfully import all the images, again, you can do the sequential image show, right? Using the for loop. So now you can take a look for the white region or bright region right here. These are actually vessels. Let's take a look again. You can see this is the vessels within the brain. Okay, these are the vessels within the brain. Okay. So right here, if you do successfully import all the images, the 3D size should be 768 by 696 by 136, because now you only have 136 slices right here. Okay. And this techniques is actually has a spatial name called TOF, time of flight, but you don't really need to learn this right now. Just remember, this is a kind of technique for MRI that we can image the vessels, okay? So I'm going to ask you, please modify your code right now. You need to first of all change the directory path right here. Sorry, I made a mistake right here. You should go for TOF. That should be the correct one. Yeah, this should be the correct one. Okay. So if you are the Windows user, you can go for this one /. If you are the Mac user, you can go for \. Okay. So what you need to do, you simply need to replace this one. And another thing right here, if you didn't use lens before, right here, if previously you put 119 right here, you need to change it, okay? Either to the 136, or maybe a better way, it should be the lens dir info, okay? So do it now. You should be able to see something. So I don't want to block the L right here. So let me draw it again. Do remember, if you put 119 for this for loop, you need to change it, okay? You need to use lens dir info. I think this is the same thing with 136 right here. Okay? And there is another difference right here. You didn't see the initial, I didn't use the initial magnification right here. Because for these MRI TOF images, they are big enough. We don't need to do any enlargement right here. So I didn't put the initial magnification right here, okay? So please modify your code, change your code, so you can actually read MRI TOF and display it, okay? I'm going to wait for another 20 seconds, but we are really running out of time, so I cannot wait too much. Okay, so if you can successfully see all the MRI TOF images on your MATLAB, just raise your hand. Okay, good. Over 10 students, very good. Okay, so I'm going to do this with you. Again, I do prepare another code for you, exercise 07 on the line 2. Anyway, so just to remember, you need to change your directory path right here. You need to make sure now you are set up the right range for the first for loop, okay? And finally, you don't need the initial magnification for the image show because it is, big enough. So maybe I should clear closal over this one. Okay, so if you make it right, you should be able to see all the 136 slides for the MRI TOF imagery. Okay, so again, I just want to emphasize that for the brighter region, white region right here, there are vessels, okay? There are vessels, like the arteries or something within your brain, okay? Okay, let's go for the next one. So now, for the step number 2, we are going to do an image process. It is so-called maxima intensity projection. So basically, we do have 136 slides, right? We do have that on hand because if you do it right, you should have this imaging variable, this image matrix. Now you can see it is 768, right? By 696 by 136, right? This is what do you have right now? And what we are going to do is that now we only know that the bright region right here represents the vessels. But if you really want to see a beautiful image on the right-hand side, this is so-called angiography. You really want to see the full structure of the vessels, you need to do this process. This is so-called maxima intensity projection. So think about this. You may have, in this demonstration right here, you may have 1, 2, 3, 4, 5, 6, 7, 8. You may have 8 slices on hand. However, if you do want to see this beautiful vessel structure, specifically these are the arteries right here, you need to project through. That means you only want to find out what is the maximum value along the slice direction right here. So if we do have the 8 slices right here, you may find out which one is the highest intensity, or what is the highest value right here. It should be this one, right? 238 right here. Okay? So you may find out the idea is that we are going to project through each pixels right here. For example, I start from this one. Okay, I will project through the slices right here. Don't forget about this. We do have 136 slices, right? So for this voxel or this pixel right here, I'm going to find out what is the maximum value along the slice direction. I can do pretty similar things for another different pixels right here. Again, I can do the search or do the projection to find out what is the maximum value. I have to say, maximum value may happen in different slides. For example, for this point, you may find out this is maybe located in the second slice. But for this one, it may occurred in the maybe third slice. Okay, so the maximum value can happen or can occur in different slices. Okay, so you need to do projection. Projection means this is kind of the search. You need to search through all the slides to find out the maximum value. By doing so, you will have the chance, you will have the result like the right-hand side. You can see the full structure of the vessels, okay? And I have to say, even the idea sounds pretty complex. Actually, you only need one single line to do this kind of projection. You can see we use the function max, right? This is a function can help you to get the maximum value. So let's help max right now. Let's take a look. I'm going to help max right now. Help max. So every single time when you see some function that you don't really know how to use it, you just help it, okay? Just wait. And then you can see the description right here. The basic way is that you can just simply input a factor. A factor, that means it should be 1 by n or n by 1 array, right? That is a factor, right? But to be very honest, right now we have a matrix. This is not a factor, right? This is a matrix. This is a 3-dimensional matrix. So maybe you can go for, I have to say, this one. This one. If you do have more than 1 or 2 dimension, you can go for this one. This one can help you to get the maximum value along a specific dimension. But do remember, you need to give an empty matrix for the second input. It's kind of the rule. Just follow it. The first input is your image matrix. The second input is an empty matrix. But the third input right here, this is the dimension you'd like to perform or you'd like to search for the maximum value. So right now, we are going to do something like searching the maximum value along the slice direction or along the slice dimension. And now we know for slice dimension, this is a third dimension, right? Okay, slice is the third dimension. So what you can do or what you should do right here is simply put something right here. We use the imaging as the first input. We put an empty array right here. This is a rule, just follow it. But now I put 3 right here because I'm going to find the maximum value along slices. Okay, so I'm going to perform this, just run these two lines. Then you may find out this is a result, right? I can just assign this maximum value to the MIP imaging. Let's take a look. What is the size of the MIP imaging? You can see this is the size with the 768 by 696. Why we didn't see the third dimension? Do remember, we only find one maximum value along all the 136 slices, right? So now we won't have 136 slices. We just get the maximum value for each single point, located in different rows or different columns. So we can generate a new imaging compared to the original one. These two imaging are generated from the same data set, or you can say same patient. But for the left-hand side, it's simply one of the slices, one of the 136 slices, right? But for the right-hand side, this is the maxima imaging, the projection of the maximum value for these 136 images right here. Okay, so I'm going to ask you to do it now. Try it to check whether you can see this kind of the maximum intensity projection image right here. So do remember, because the maximum value, I mean the white region right here represent the vessels. So we use the maximum function to search for the maximum value because we want to see the vessels, right? Okay, so do it now. Okay, so again, I just want to emphasize that every single time when you are using the max function right here, if you want to change the dimension, you need to give the input for the third position, not for the second position, okay? second position, it should always be the empty matrix right here, okay? So now think about this. What we just did, we just performed the projection along the slice, right? So let's see for the first image right here. This is what we just got, right? But actually, for this number one image right here, we actually do the maxima intensity projection along the slice direction, right? So now think about this. Can I do the projection along different dimension? Supposedly we can do this, right? Since we can project or search for the maximum value along the slice direction, maybe we can search for example, column direction. So think about this. Which dimension is column? The first one or the second one? We know the third one is the slice, right? So if we would like to search for the maximum value along the column, it should be the second dimension, right? Because the first dimension is row, second dimension is column, right? So now, if I can make the projection along the column direction, you will get the tracer image right here from different angle. Because when you try to do the projection along slice, it's pretty similar like you are looking at the human vessels from top, right? Because it is the projection along the slice. But if you can do the projection along the column, then it's pretty like that you are looking at this patient, the vessel of this patient from the left-hand side or maybe from the right-hand side. Okay, so it's more like the lateral projection or lateral view right here. So let me do this. What you can do right here, let me just give you another example. You may think about this. Okay, what I can do right here is I can just simply change this one, right? Because I say for the dimension number 3, third dimension, it is a slice. So if I'm going to project through the column, I need to change the number to 2, right? Okay, so let me do this first. What you can see. First of all, you may see some error message. Please follow me. This is very important. Please follow me. Pay attention to me. Okay? You may find out there is an error message right here. So you can see some error message right here. Multiplane imaging inputs must be RGB images of size like m by n by 3. But let's check what is the size of the MIP image right here. You can take a look right here. It is something like 768 by 1 by 136. Something wrong right here. You do see a singular value right here, 1 right here. I have to say, because now you are doing the projection along the second dimension, right? So basically, you will make this 696 become 1 because you are doing the projection along this dimension. However, if you really want to use the image show doesn't allow you to input such matrix for display. You can simply input the matrix like a 2-dimension or like this one. If you are going to go for a 3-dimension, it will treat it like a color imaging. So the final dimension should only be 3 because you have the red, you have the green, you have the blue, you have 3 labels right here. Anyway, so now the only solution that you can do right now is you need to get rid of this dimension. You need to remove this dimension because you only have 1, right? 1 means you don't need this one. So you can remove this one. So there is a very good function called squeeze. Squeeze is a method function that can help you to remove singleton dimension. You can simply remember singleton means dimension with 1, okay? Dimension with 1, you can remove it. So what I can do right now, you can check. Now I can do something like, maybe I can put right here. Before I can display it, I can use the squeeze. Okay, so squeeze will help me to remove this one. If you want to check, let me do something for you. For example, like this one. I just want to know what is the function of the squeeze. Now you can see A right here. Okay, it simply remove this one right here, right? So it helps you to create a two-dimensional image by removing this singleton dimension. Okay, so now let me try it again. Can I display the image? Now you see something, right? Now you didn't see any error message, and then you do see something. However, you may say, I don't think the direction is right because I need to turn my neck so I can see, I can understand it, right? So maybe you need to do something like a transpose, right? Transpose, okay? So now you may think about something like this one, transpose. Do you remember this quotation mark, single quotation mark represent the transpose for the matrix, okay? So let me do it again. So now you can see, okay, it's come to a better place, but now you may think, no, actually, it is upside down. Because here is the neck. If you do know the anatomy of the cerebral vessels, here is the neck. Here is the top of the brain. Okay, so you need to do something to flip the image to make sure the upside should be, flip into the right position. So there is another function called this one, flip. UD, U means up, D means down, just upside down, okay? So what you can do, again, I'm going to put this right here, upside down right here. You can see I can just try to increase the code, okay? So now I'm going to run this code again. Now you can see, compared to a previous condition, let me show you. This is the original one, right? This is the second one. This is the final one. So this is the one that you only use the squeeze. This is the one that you use the transpose. And this is the one that you also use the flip up and down. Okay, so now you can see this. The final thing that you may need to know is that actually the dimension is not perfect, but I don't think I have time right now, so maybe just stop right here. I just want you to understand that you should be able to display this kind of imaging, okay? And I want to give you the homework right now. I think the homework is pretty similar to this one. We did perform the projection along the column, right? So the homework, I'm going to ask you to perform the projection along the row direction, the final dimension that we didn't mention, right? So I'm going to ask you to use the subplot function again. I'm going to ask you to display the all three different views right here. This is the one that we generate for this part, okay? You need to put this image in the same position that I did. And this is the top view, this is the lateral view. And we do have another projection, dimension number 1, okay? I want you to put it right here, okay? Somehow you need to do something like transpose or flip up and down. You need to do pretty similar things right here, okay? But I have to admit, I don't have time to explain what is the D aspect right here. But I think we can skip it right now. Just go for your homework. Try to make the final projection, okay, along the row direction, and then finish your homework. Okay, I think that should be all for today. So if you do have the question, just raise your hand. We can help you, okay?